So we're looking at 25A, the proportion of women who've had multiple births. We're seeing if there's a racial difference between white women and black women. And we're going to use the calculator to do our calculations because, yay, who wants to do all this stuff by hand, right? So we checked our conditions. They're good. I'm not going to go over that because we've talked about that a lot. So in our calculator, where do we find our tests? Stat tests. There we go. We're going to go down to the two proportion z-test, two prop z-test. And we're going to hit enter. Now it asks me for x1. That's the numerator of p hat, in this case w, 94, and n1, which is 3132. And my x2 is 20 over 606. These numbers, x1 and x2, must be whole numbers. If I am given a proportion 0.21 and I have to multiply that by 3132, I need to do that but round it. Your calculator will give you an error if you don't put in a whole number. x1, n1, x2, and n2 must all be whole numbers. Because we're talking about the number of people that had multiple births. It can't be a half a person. And then my alternative hypothesis, we're selecting here where it says P1 not equal to P2. So it's not equal to, less than, or greater than. And then we hit calculate. And look at that beautiful magic. My z-score is negative 0.39. My p-value is 0.695. It tells you what my p hat 1 and p hat 2 are. It tells you what p hat pooled is. That's what this p is. P hat with nothing under it is your p hat pooled, and it gives you your n's. Okay.
So most of the time, are we doing not equal to?
It depends on the question. This one asked if there was a difference. So if there's just a difference, we're going to do not equal to. If it indicates has it increased or has it decreased, that's when we're choosing greater than or less than, depending on how we subtract. Just really make sure that you're choosing the correct alternative hypothesis based on how you entered the data into the calculator, which one you chose to be your x1 and your n1. And then I also want to show you what happens when I go back to the test. Say I need to create a confidence interval. If I go down to the 2 prop z int, it already has the data in there for me. It asks for the same thing, the numerator and the denominator of each of my proportions. I can put in 0.95 if I want, and then I can hit calculate, and that will give me my confidence interval. Okay. You are now given permission to use the calculator for all of your 1 prop, 2 prop, z-tests, and intervals. Yes, I am. Okay. So, this was my interval. X1 is our numerator of p hat 1, and 1 is the denominator of p hat 1. They must be whole numbers. And then x2 and n2 are the numerator and denominator of the second proportion. Always need to put those in as whole numbers. So we got a p-value. Now, when you're doing this in the calculator, you need to write down 2 prop z-test. Then you can write your z was negative 0. If you pick the wrong alternative, you're going to get the wrong and the P is 695. That's really all you need to write down, the Z and the P. Okay. And then we can interpret our p-value. If there was no difference, if there is no racial difference in multiple births,
So as far as like when you're finding the p-value after you do normal CDF and you times it by 2, you're only doing that when it's not equal to?
correct, we only multiply the p-value by 2 when it's not equal to alternative hypothesis. Okay, so again, we state if our null hypothesis is true, if there was no racial difference in multiple births, there is a 0.695 chance of obtaining a sample difference as or more surprising or extreme than, and when we subtracted them up above, we got 0.003. Right? That was the 0.03 minus the 0.033, 0.003. Okay? Which is very likely, right? A 69% chance of that happening. We have to remember that the p-value is how likely it is that this is just sampling variation. So if it's high, that means there's no reason to believe it's not the null hypothesis. Robin? That was the difference we did over here. Hold on. We subtracted the two proportions right here. It's the difference in p. Trying to get a color. Right? The calculator does not calculate that difference. It gives you the two p hats, but you still have to subtract them by yourself. Yeah. Okay, so that means we fail to reject. Our p-value is high. Yeah.
So we would need to put this sentence and we fail to reject.
Yes. On my test, yes. Right. There is not enough evidence to convince us that there is a racial difference. Yes. So
if there was, what would that be proving?
that one race is more likely to have twins than another.
That's all?
It doesn't really prove it. It just shows that that sample showed that there was a higher instance one over the other. Since my p-value of 0.695 is so high, I fail to reject that high. When it's 695, like it's not even close to an alpha level, right? So you can say because it's so high, and if it's super, super low, like 6.2 times 10 to the negative 8, you can say because it's so low, small, right? If it's close to your alpha, that's when you really want to make that comparison. It's higher than my alpha. It's 0.06, and my alpha is 0.05. That's where you really want to make those comparisons. But when it's super high, you can just say because it's so high. I failed to reject the null hypothesis. Right? It's high, so I'm failing to reject. I used capitals on your grading just to emphasize that there is not enough evidence. If I'm failing, there's not enough evidence.
And that's less, if you're failing, that's type 2 error possibility?
Yes, that's type 2 error possibility. So there is not enough evidence to convince me of a racial difference in multiple births.